Welcome to sidschemistry. Today we are learning coordination compound multiple choice questions and their answers. Our first question is, which of the following complexes formed by the copper 2 plus ion is most stable? We have given 4 reactions in which copper 2 plus ion is attached to the different ligands and they form a particular complex. We have also given values of their equilibrium constant in the log format. Now, dear friends, we need to understand that the value of K, if it is high, then the product value, that is the complex ion values, are accordingly high. Now, stability means we have to understand that which of the particular complex ion will remain stable, and stability indicates that the amount of the particular complex ion will be high after we calculate the log K value. What I mean to say that if we have ratio of product to reactant, that is log K value is high, then the stability of complex ion will be high, and you can see that the circled one has highest log K value. It means that the proportion of CuCN42 minus will be higher as compared to the reactant molecules. It means that copper 2 plus ion and Cn minus ion, and therefore the most stable is the option number 2. Now coming to the second question, the color of the coordination compound depends on the crystal field splitting. What will be the correct order of absorption of wavelength of light in the visible region for the complex is given. Now we must need to understand the stability of the ligands or the strength of the ligand before we answer this question. The strength of ligand, if we consider Cn is more stable, then amine is more stable than aqua, and therefore depending on the stability, the splitting value will be high. If splitting value will be high, the energy will be high, and if the energy will be high, the wavelength will be less. So we have to consider that the ligand which is the least stable has the highest wavelength in its particular complex format, and we can see that we have to arrange aqua as the highest value, and we can see that it is only available in option number 3. So aqua is more than amine is more than cyanato, and therefore the correct answer for this particular question is option number 3. Coming to the question number 3, when 0.1 mole COCl3 NH35 is treated with excess of AgNO3, 0.2 molar AgCl is obtained. The conductivity of solution will be correspond to. Dear friends, when 0.1 mole of the COCl3NH35 is treated with the excess of AgNO3, we are getting 0.2. It means we are getting double the amount of the complex treated with the AgNO3. Now it means that there are 2 chlorine ions are available to react with the excess AgNO3, and therefore we are getting 0.2 mole of AgCl. So the ratio of complex to AgNO3 or ratio of complex to the AgCl will be 1:2, and option 2 will be the correct answer of this particular. Now coming to the question number 4, when 1 mole of CrCl3 6H2O is treated with excess of AgNO3, 3 mole of AgCl are obtained. The formula of the complex is. Dear friends, it is a similar question similar to the question number 3, and therefore we have to look that how many Cl minus will be available to form 3 mole of AgCl. If we want to form 3 mole of AgCl, we must have 3 Cl free in the form of ions, and that can be available in the option number 4 only. So the correct answer will be option number 4. You can see that this particular complex can form 2 ions, and the complex ions are Cr H2O6 3 plus and 3Cl minus. These 3Cl minus will be available to react with the AgNO3 to form 3 mole of AgCl, and therefore the correct answer is option number 4. In the other options, the availability of Cl minus ion is not sufficient to form 3 mole of AgCl. Now coming to the question number 5. The correct IUPAC name of PTNH32Cl2 is, we have to arrange the ligands first in alphabetical order, and therefore we have to speak that diamine dichlorido, they are the ligands present in this complex. Diamine dichlorido is available in 3 options 1, 2 and 3, where it is written like diamine dichlorido. Then we have to write the name of the metal ion, that is platinum, which is also given in all the 3. The main thing is that we have to put the correct oxidation number, and if we can find the correct oxidation number, then that will be the correct answer. Oxidation number can be obtained by using the formula that the charge of the complex minus total charge of the ligands available in the complex, and therefore we know that the charge of this complex is 0 minus total charge of the ligands present inside the complex. So the charge of the amine will be 0, but charge of Cl is -1. There are total 2 chlorines present, and therefore the total charge will be -2, and therefore the oxidation number will become +2, and the correct answer is option number 1, that is diamine dichlorido platinum 2. Now coming to the question number 6. The stabilization of coordination compounds due to chelation is called the chelate effect. Which of the following is the most stable complex species? Out of the given 4 options, we can see that in the first one, carbonyl ligand is given, which is monodentate. In second one, cyanide ligand is given, which is also monodentate. In third one, oxalato ligand is given, which is didentate. And fourth one, water ligand is given, which is monodentate. It is already given in the statement that chelation is responsible for the stability, and only chelating ligand is present in option number 3. So the correct answer for this question is option number 3. Coming to the question number 7. Indicate the complex ion which shows geometrical isomerism. For the geometrical isomerism, we have to have such condition like M means metal ion, 2 of A kind of ligand and 2 of B kind of ligand, then only we can form such kind of geometrical isomerism. Otherwise we could have M A2B4 in case of total 6 ligands present, or M A4B2, that can also produce the geometrical isomerism. We can see such kind of condition M A2B2 in option number 1, where in option number 1 we can see such kind of condition that M A4B2, and therefore it can be a geometrical isomerism. While in option 2 we could not have such condition, in option 3 still we have not such kind of condition, in option 4 we have not such kind of any of the conditions, and the correct answer will be the option number 1. Now going to the question number 8. It is very important question. The CFSE for the octahedral COCl6 4- is given 18,000 centimeter inverse. The CFSE for the tetrahedral COCl4 2- will be what? So we have to locate the energy first of all. This is the full form of CFSE is crystal field stabilization energy. We have to also look at the tetrahedral and octahedral value. Now there is a formula of comparison between the tetrahedral energy and the octahedral energy, and the formula is delta T is equal to 4 upon 9 of delta O value. So we have already given the delta O value, that is 18,000. So if we put 18,000 value here, we can get the value for the delta T, and delta T means tetrahedral, delta O means octahedral. So when we solve this question, we will end up with the answer option number 3, 8,000 centimeter inverse. Now coming to the question number 9. Due to the presence of ambidentate ligands, coordination compounds show isomerism. Palladium complexes of the type PDC6H52, SCN2 and PD66H52 and SC2 are what kind of isomers? We have 4 options: linkage isomers, coordination isomers, ionization isomers, geometrical isomers. We can see that this is thiocyanato and this is isothiocyanato. Now thiocyanato sulfur is linked with the palladium, and isothiocyanate nitrogen is linked with the palladium, and therefore this is a case of linkage difference, and therefore the isomers are also called as linkage isomers. So correct answer for the 9th question is linkage isomers. Now coming to the question number 10. The compounds COSO4NH35 Br and COSO4NH35 Cl represent. You can see that Br and Cl, they are the exchange in the form of ligand and the counter ion. So when such kind of condition happens, different ions are produced, and such kind of different ions but the same molecular formula will form ionization isomerism. So the correct answer for the question number 10 can be the ionization isomers. However, let us see the other options available and then finalize the answer. We have coordination isomerism and we have no isomerism in the 3rd and 4th. Now going back to the question and let us find out what happens. Let us first of all compare, are the molecular formula same or different. COSO4 is present in both the sides. NH35 is also present both the sides. Well, we have Br and Cl. Now we can see that they are totally different. They cannot form even ionization isomers, because for ionization isomers we could be only doing the same thing when we have same molecular formula. But we can see that in the question number 12 the molecular formulas are totally different, and therefore we cannot end up with the ionization isomers. However, we can go for the option number 4, no isomers, because molecular formulas are different. So the correct answer will be option number 4. Now going to the question number 11. A chelating agent has 2 or more than 2 donor atoms to bind to a single metal ion. Which of the following is not chelating agent? Dear friends, we need to identify the polydentate ligands out of the given options, because polydentate ligands can only form this kind of chelating isomerism or chelating compounds. Now thiosulfato has 2 donor atoms, but it is not a bidentate ligand because it is considered as an ambidentate ligand. At a time only one of the oxygen of the thiosulfato can be donating agent, and therefore it can be the correct answer. However, let us see the others. Oxalato is a bidentate, so it cannot be the answer. Glycinato is a bidentate ligand, so it is not can be the answer. Ethane 1,2-diamine is also a bidentate ligand, so it is not an answer because we have asked that not a chelating agent, and this all 3 are chelating agent as they are bidentate ligands. Thiosulfato has also 2 donor atoms, but it is considered as ambidentate ligand. An ambidentate ligand cannot form a chelating compound. So therefore the correct answer is option number 1. Going to the question number 12. Which of the following species is not expected to be ligand? NO, NO is expected to be ligand, NH4 plus. NH4 plus is not a ligand because the lone pair is available to the extra hydrogen and it is a positive ion, and therefore it is not a ligand. Here two nitrogen atoms in the option number 3 are the donor atoms. Here carbon or oxygen can be donor atoms, and therefore option number 12 has only one answer, that is NH4 plus, option number 2. Going to the question number 13. What kind of isomerism exists between CrH2O6Cl3 violet color and CrH2O5Cl Cl2H2O grayish green color? When the water molecule comes out from the ligand moiety to the aqueous moiety attached to the complex, it could be understood that it is a solvate isomerism, and therefore for the option number 13 the correct answer is solvate isomerism. You can see that water molecule here is also taking part as a ligand in the another complex, and therefore the correct answer is option number 2, solvate isomerism. Coming to the last question of this session, IUPAC name of PTNH32 ClNO2 is. First of all, we have to arrange the ligands in alphabetical order. We can see that there are three ligands: amine, chlorido and nitrito N. So we have to arrange them accordingly. First of all, amine A comes, and there are two, so diamine. Then after chlorido comes, so chlorido. Then nitrito N comes, so nitrito N. And then after platinum metal comes, so platinum and platinate is given. So up to the arrangement of nitrito N, these two options are correct. But after that we can see that at one point it is written platinate in the fourth option. Platinate or 8 suffix can be added after metal only when it is a negative ion in the complex format. But here the whole complex having no charge, and therefore we could write only platinum. Platinate is the incorrect one, and the oxidation number is 2. Therefore the correct option for the question number 14 is option number 3. I hope you enjoy the session. We will be coming up with more chapters in our later videos. Thank you for watching. We love to educate. If you have any queries, you can put a message directly on our email address sidschemistry@gmail.com. Thank you for watching.